is loading part, and next is linking part, and then initialization. Three things are there. So it does three things. First of all, it will load the classes. Like I said, the classes must be loaded in method area. And one more thing I will tell you here, listen carefully, the very important thing. Whichever class is loaded, its object will also be created inside heap area. Its object will be created inside heap area, right? So that it supports a reflection API. Okay, we will be learning about reflection API. So it supports reflection API. So a class object will be created here, and the methods will be loaded here. So loading has three parts again. There are three types of loaders. One is bootstrap loader, and extension class loader, and application class loader. I will explain these. See, application class loader will load those classes that belongs to our application. Means our own program when we write, and if we write our own classes, those will be loaded by this application class loader. Then bootstrap loader and extension class loader, these loaders will load the runtime classes that are required by JVM. See, all the library classes of Java, like Java Standard Edition, Java SE, all those classes, whichever class is required, will be loaded by this bootstrap loader. So this bootstrap loader is responsible for loading Java SE classes, whichever are useful in our program. Then extension classes are useful for runtime environment, providing runtime environment by JVM, and these classes are loaded by extension class loader. If you want to see what classes are loaded by Bootstrap loader, this one and this one, I will show you the path in JDK 1.8. See, this is C drive, and inside this program files Java folder. If Want to see what classes are loaded by Bootstrap Loader? This learning is based on Java 1.8. So, for explanation, I have downloaded the folders of JDK to explain you what does Bootstrap Loader do and extension load class loader do. So, this GRE folder, if I get inside this one, library folder, inside this, you will find one file called rt.jar. This file. This rt.jar file will contain all Java SE classes, and this will be loaded by Bootstrap Loader. Then there is a folder called extension. If you get into this, there are some jar files containing the classes that are useful for JVM at runtime. So these are loaded by extension class loader. An application class loader will load our classes, whichever program that we want to run. Let us go back to the diagram. So this is about loading. Now next process, this is done at the loading process. So you prepare will allocate memory for static variables that are used in our classes. Then lastly, resolve. As this is linking process, so actual process of linking is here. Suppose there is a method called fun1 in our class. It is done by class loader as are maintained if there are three page collector. If a program is creating an object inside heap and if it is not using it after some same what we have discussed in the beginning. So that's all. In this lecture, I will talk about features of Java that are called as buzzwords. Some of these features are the topics in this course, like multi-threading as a topic, a big topic in course. Anyway, it's like an introduction. We will go through these features. The very first feature is Java is simple. They say that Java is simple. The reason of saying it's simple because a programmer, if he's coming from C or C++ programming, then he find the syntax of Java similar to C or C++. And even if you're learning Java as your first programming language, then it is not much difficult to understand. It is more simple, just like English language. Now, next thing is secure. Java is secure. The reason of calling this as secure as it cannot get viruses infected by viruses or it cannot be attacked by any malware. The reason is Java virtual machine that we have studied about it. It is having a security manager or a verifier which verifies Java code and confirm that there are no bugs in the code or there is no malware or there is no malicious code in Java. So JVM will not execute if there is any malicious code in your program or any malicious code is trying to harm your program. So Java runs within the shell of this JVM, so it is secure. See, we already saw this diagram that Java programs run inside here, JVM. So this will take care and this provides security to Java program. So that's how Java is secure. Now next is portable. We have learned about platform independency feature of Java that Java programs can run on any platform. So if you have written Java program on Windows, then you can port them on other platform like Linux and you can run them there. So Java can move on from one platform to another platform. So that platform independency brings in portability feature in Java. See, we saw this diagram that Java program once compiled on any operating system, it can run over Windows, it can run over Linux or Mac or any operating system it can work, provided JVM must be there. So that's how Java programs are portable. So this is over. Now let us look at object-oriented feature of Java. Object orientation is a style of programming. This is a paradigm, a method of developing applications. And the principles of object-oriented programming are abstraction, encapsulation, inheritance, and polymorphism. We will learn about all these features. This comes under basics of Java programming. We will learn about this one. So it is object oriented. So object oriented language are very easy to learn and they look more like English language. That's how Java becomes simple. Now, next is Java programs are robust. Robust means they are strong, they never fail or they never crash, even in worst conditions. So, what are worst conditions? During the runtime, if a program requires any resources and the resources are not available, usually programs crash. The programs of C, C++ may crash if they are not written properly. But Java guarantees that even if there is unavailability of resources, the program remains executing. It will not crash unless and until a user stops the program. So this feature is achieved by using exception handling. This is achieved using exception handling. We have a section on this one. We will be learning about this exception handling. So Java programs are robust, strong. Next is multithreading. Java supports multithreading. Multithreading means we can break a single program into multiple pieces so that they can run simultaneously. We have to learn about more about this one, multi-threading, so just name is sufficient here in this lecture. So Java is multi-threaded. Next is Java is architectural neutral. So it is architecture neutral means it is hardware architecture neutral. There are various hardware architectures, right? So the commonly used architecture is von Neumann architecture. There are other architectures also available. Commonly, we are not aware of them. Like the most famous one is von Neumann's architecture. All the computers, all laptops, machines that we are using today are based on von Neumann's architecture. So Java runs on von Neumann's architecture. ARM is an architecture that is used in mobile phones. The processors in mobile phones they are based on ARM architecture. So this architecture is a little different from von Neumann. If you want to study it, you can study it. But the hardware is of ARM is not exactly same as von Neumann. It's a variation of von Neumann, or it's somewhat different from von Neumann. Next is RISC, that is Reduced Instruction Set Computer, and ARM is based on RISC architecture. And there is one more complex instruction set computers are also there, and embedded architecture is also there. So if you are interested, you can study more in detail about these architectures. So the commonly used one is von Neumann. So Java can run on any architecture because Java is not dependent on hardware. Java runs inside its own JVM. So if JVM is available on any hardware, then Java can run there. So that's how Java is architecture neutral. Next is Java is interpreted. We know that Java uses interpreter as well as a JIT compiler. Already have explained you this one. So Java is interpreted language. Being an interpreted language, Java is a little slow compared to C and C++. Now, in the beginning, early versions of Java, programmers were complaining that Java is very slow. So later on, they introduced JIT compiler, which made Java faster. So though it is interpreted, it is high performance. So this is a feature. So this is together. It is interpreted, but it is of high performance. It has to be understood like this. The next is Java is distributed. So Java supports distributed computing. So this is a picture of distributed computers, like multiple computers are connected together in a network. And the programs running on these computers, they may collaborate together and work as a single computer or single software. They may work together as a single software. So a Java program can be divided into multiple components, and the components can be deployed and execute on various computers, different computers, and all those components together can work as a single program. So this is called as distributed computing, and this is mostly useful in businesses which are spread across the globe or across a country, where various branches of a business are working framework for developing this. So it can component and so that's all. These are the features of Java. So I have just given the introductions, and some of the features require more in-depth knowledge, then you can understand them thoroughly. So that's all in this lecture. The topic is operate. Yes, we'll learn about operators in Java. I have written the operators here, like increment, decrement operators, then arithmetic operators, bitwise operators, relational and logical. So in this video, I'll be covering about arithmetic operators first, then I will explain you about increment and decrement operators. So for learning about these things, I'll explain about the operators, means what they do. Then I will show you how to write down the expressions. And what is important in expression is precedence and the result of the expression. That is data type of the result of the expression. So as these operators are useful for writing expressions, we should know about the precedence of operators and the result of the expression. So these are the important things we will study. So first let us study about arithmetic operators. About arithmetic operators like addition, subtraction, multiplication, division. So these are the basic arithmetic operations. Then first thing, these operations can be applied on any type of data except Boolean. It means we can perform operation on two integers, right? And we can perform operations on two floats, or we can perform operations on double, we can perform operation on character also. But this is not allowed on Boolean. These operations cannot be performed on Boolean, arithmetic operations. Like addition, subtraction, multiplication, division, I don't have to explain anything. But mod is a special thing. Let us learn about that. What is mod? So for explaining mod operator, suppose I am saying 10 mod 3. What does it mean? I want the result in x. And also I said y assign x 10 divided by 3. So if I say 10 mod 3, what is the result? And 10 divided by 3, what is the result? Let us see. See, this dividend is 10 and divisor is 3. Then if you divide 3 times is 9 and 1 is remainder. So this is quotient and this is remainder. This division operator gives quotient. This gives quotient, that is the result will be 3. And this mod operation gives remainder, that is 1. So when you perform division operation, there are two results. One is quotient, another is remainder. So if you want quotient, you use a divide operation. If you want remainder, then use mod operation. Then one more important thing about mod. This operator can work on float and a double also. Let us see how it works. If I'm performing mod on 12.7 mod 3.1, then what will be the result? Suppose I want to take it in x. Then this 12.7 divided by 3.1, it gets divided by 4 times. So 4, so this is 3 fours 12 and 4 ones 4. Then what is the remainder? Remainder is 0.3. Yes, we get this remainder, 0.3 is the remainder. So when you have a decimal number, then there is no remainder, right? In basic mathematics, there is no remainder. But in Java, mod operation works on decimal numbers also, that is float number also. So how it works? Actually, in quotient it will not take decimal. Don't take decimal here in quotient, right? If you write decimal here, then again at some point it gets divided. So don't. These operators have higher precedence than these operators. Multiplication, division, and mod are having equal and higher precedence. When they all are same precedence, but they have higher precedence compared to addition and subtraction. So if in an expression, if you find multiplication or division or mod, that will get executed first, then addition subtraction is done, right? So you should be familiar with this one. So if you want to change the precedence of operators, suppose you want addition should be done first, then multiplication, then you should use parentheses. So parentheses are used for changing the precedence of operator. So while writing the expression, you must be careful with the precedences. So I have taken some examples here to explain you. See, suppose in mathematics, making it work, we want like this result of the data type of expressions. Result of this expression will be of which type? Byte type or short type? So I wrote X here. Just I want to know what should be the data type of X. See, remember, whether you add 2 bytes, okay, or 2 short, or you add byte with short, whatever the operation will be, you will not get the result as byte, but you get the result as integer, because all these are integer type, and those are the subtypes, and those are in smaller size compared to integer. So as I said, the basic data type is integer. Then we have long, that is double the size. Byte and short are provided by Java for backward compatibility, right? So that's why this doesn't give a byte type result. So the operation is treated as integer operation only. So this means that when we write 2 bytes, this plus operator assumes that the value of these bytes is nothing but integer. That is the reason it gives the result as integer type. And for short also, it assumes that these are integer type and perform the operation and give the result as integer. So it means compiler will internally convert this into integer types. That is the reason the result is integer type. And this process or this mechanism of compiler is called as coercion. It is called as coercion. So internally it will convert the data type. So this byte and short gives what? Integer. Short and integer gives integer. Now comes integer and float. So I have taken the initial of each data type. I means integer here, F means float, right? So integer and float, if these are performed with arithmetic operation, any one of these operation, then what is the result? Integer with float. See, integer is without decimal. Float is with a decimal, has mantissa and exponent part with a decimal. So that needs little extra processing. Already I said that. So the result of this one will be float. This will be float. Right? If float is used in the expression, means the result is going to be float. Right? If you have integer also, the result will get converted to float. So this means what compiler will do? Addition, it will not whatever you are doing, result is result is in the double. Again, long tail, the double addition is done and the result. Let us look at the demonstration of arithmetic operators I have explained you on whiteboard. So let us check them practically here. So for giving demonstrations, here I am using NetBeans IDE because it is easy for explanation.
அதாம்மா அப்பா ஏதாச்சும் நான் சாப்பிட்றதுக்குதா என்ன டிஃபன்? நான் குளிக்கல, மத்தியானமா குளிக்கிறேன். என்னால் முடியல. ஆ ம்